Alright guys, this is geotrig. We are going to call this one solving trig equations. I'll even put on here day 1. So we got to the point where we could take a sine of 30, take a sine of pi over 6. Those equal 1/2. That's great. We can do that with sine, cosine, tangent, cosecant, cotangent, and cosecant. Secant, cosecant, cotangent. I think I might have messed that up. And we could evaluate them. Sometimes they're the reciprocals of sine, cosine, and tangent, so what we call the little three, I call the big three sine, cosine, tangent themselves. And we've dealt with many different things of them. Finding coterminal angles, we found that sometimes you had to do it in degrees or radians. We also had to get a common denominator while doing a couple of them and putting them together by adding and subtracting them, or even multiplying them. And then we went to taking powers of them in the last video. Today we're actually going to reverse the role here and say, hey, what if I gave you an equation? Now if I gave you a really simple equation that looked like this, you guys would know what to do. You would just, subtract, it's 2x minus 1 equals 0, so you would add 1. So if I add 1 to both sides, I get 2x equals 1. Divide both sides by 2. I get x equals 2. And if I get x equals 2, you know that 2 is the solution to this equation that would make the equation equal 0. What we're going to try to do then is do the exact same process with this equation. The process is the exact same. If we were to get x by itself, we are now going to get the sine theta by itself. So we're basically taking out x, right here, move x, place the trig function in. So I can do exactly what we did before, which means I need to isolate the trig function first. Then what we're going to do is we're going to use the idea of use your trig or your unit circle. Most of it's always going to be on a unit circle, and we're going to say, what does it equal? So give or take. Understand that we would add 1 to both sides, and so you're like, hey, that's 2 sine theta equals 1. Divide both sides by 2. So therefore, I get sine of theta equals 1/2. And so this is where you start to say, hey, on my unit circle, hey, I've seen 1/2 before. I said, hey, wait a minute. I know that if I take the sine of 30, I will get 1/2, or pi over 6. It matters if we're in radians or if we're in degrees. So your eyes would hopefully make this little graph and say, hey, wait a minute, 30 degrees. So x, or did I use x? Or theta, sorry. So I'm going to take that out of there. Theta would equal 30 degrees. But I'm hoping that you guys remember back to when we were taking the inverse sine, cosine, and tangent, because that's technically what we're doing here, is if we wanted to do this correctly with a proper notation, I would take the inverse sine of both sides. And if I take the inverse sine of both sides, this right here is a lot like what we did the day before, or the lesson before. And that was, you take, hey, theta equals the inverse sine of 1/2, and you look at your unit circle, you would look at the fact that sine inverse positive only exists in quadrant 1, hence we wrote it here in quadrant 1, and it associates with 30. But here's the thing. We only worry about a particular quadrant, like quadrant 1, or if we're talking about quadrant 1 and 4, 1 and 2, it matters which function we're talking about, when we are talking about the capital RA in arc sine, arc cosine, and arc tangent. Now, we're using inverse. I'm not just looking for one answer, I'm looking for all answers. So I'm hoping you guys also realize that if you looked on this side of your unit circle, take the time to do that, you would also notice that this angle at 150 degrees, and that's a really bad 150, would also equal 30 for the sine. So the sine of 30 is 1/2, sine of 150 equals 1/2. So that is how you're going to solve 4 theta or an x or something. It matters what the variable is. It doesn't have to always be theta. A lot of times it will be. And it's kind of funny that I already talked about this without turning the slide, is that the fact that every trig function has 2 quadrants where it's positive and negative. Therefore, there's always going to be more than one answer. Now, I say that it's going to be more than one answer. It's actually the fact that it matters what your domain is. If they say only between, on this last problem we just did, between 0 and 90 degrees, well then 30 is your only answer because 150 was not in that domain. But be careful that there is definitely going to be 2 positive and 2 negative answers for any particular one. So is it a positive 1/2? It happens twice. Where is there a negative 1/2? It would happen twice. Plus, don't forget that the unit circle is just a big circle. You can keep going around and around and around and around, actually going this way, around and around and around the circle, and I can happen at 30. I can go around the circle 360 and end up at what? 390. I can go around the circle again and end up at what? 7, so 390, 750 is it? And so I can keep going around forwards or backwards. So there's got to be a way to deal with this. So we said before, hey, theta equals 30 degrees. We need to then talk about the fact that, hey, we could be in radians. So I could say, actually, pi over 6. So theta equals pi over 6. But I have to take in consideration that I can go around the circle 360 degrees forwards or backwards. I got to take all answers in consideration. So if there's no limit, so the domain has no restrictions, I need to put plus 360k. Now, what does that mean? It means 30 plus 360. It's 30 plus 360 times 2. It's 30 plus 360 times 5. It's every whole number or integer, right? Say a whole number. Integers, positive and negative. Values of k. So I can multiply it by -1, -2, -3, 0, that would make it just 30, or 1, 2, 3, 4. And I can find all or infinite amount of answers that when I go to the circle, I'm here. Add 360, I'm here. Add another 360, I'm there. And again, and again, and again. Or, again, I can take the 30, which is here, and subtract 360. Subtract 360, subtract 360. I keep coming up to it. And so if I'm in radians, it's the radian measure plus 2k pi is what they usually like to use, where k is in between the 2 and the pi, because k is technically a coefficient. It's a number, so therefore, since pi is irrational, we always stick that at the end. So, again, what we're doing here is if there is none of this stuff here that says, hey, it goes between 0 and 360 or 0 and 2 pi, then you have to say, if there's none of that there, you need to state plus 360k or plus 2 pi k or 2k pi for your answers. What this last line is saying, though, is that if it does say it falls between 0 and 360, then I can go back to what we did here and state just 2 answers. So if this problem said 0 is less than or equal to theta, which is less than 360, those are my only 2 answers. And if it doesn't, then I would have to write this to represent every possible answer that I could come across. So now we're going to start doing some problems. So I have a couple problems here, and we're going to figure this out. So I take out your unit circles, follow along. I started off pretty easy. I've already got this isolated, aka solved for me. Where does sine of theta equal a 1 over square root of 2? Now some of us might be like, hey, I don't like this, I'm going to fix it. So therefore it becomes square root of 2, over 2. Okay, so because that's on my unit circle somewhere. It's actually in several places. I'm also hoping that everybody be like, hey, wait a minute, it's a sine value. And it doesn't tell me there's any restrictions. So sine is positive in the first quadrant and it's positive in the second quadrant. And if you take a look here, this angle that would be associated to get me a square root of 2 over 2 is actually 45 degrees and 135. Take a look at your unit circles. That is where it's going to be. So how do I rate my answer? It's 45 degrees plus 360k. It's 135 degrees plus 360k. So what we're doing is we're finding all solutions. That means I could rotate 360 degrees, 360, 360 in both directions from those angles, and I will always come up with an answer for the sine of it, 1 over square root of 2 or square root of 2 over 2. So then we kick it up. I've got two changes on this particular problem. The first change is we actually have to solve for the secant, aka I'm probably going to solve for cosine instead. Then we also have to take a look in the fact that there are some restrictions going on. I'm only looking for the answers between 0 and 360, aka 1 full revolution. There shall be 2 answers. Okay, so here we go. I'm hoping everybody would understand. I'm going to subtract 2, so square root of 3, secant theta equals negative 2. Divide by square root of 3. So these are gone. I get secant theta equals a negative 2 over square root of 3. And again, I don't like secant. Secant is really 1 over cosine. So this becomes 1 over cosine theta equals negative 2 over square root of 3. Here's the really cool thing about fractions. If I decide to flip, as in take the cosine, bring it to the top, bring the 1 to the bottom, that's taking the inverse of this side. I have to do it to the other side. So if I flip one fraction, I flip the other fraction. Guys, this only works when you have a fraction equaling a fraction. If you do it any other time, you are going to have some big issues. So, therefore, the cosine of theta over 1, which is just cosine, will equal a negative square root of 3 over 2. Now, Mr. Konchak, wait a minute. You did not change the negative. That negative should be on the bottom. Guys, remember, negatives don't matter whether they go to the bottom or to the top. That fraction is just negative. And so now you just have to ask yourself, where is cosine negative? And if I go here, cosine is the x value, cosine is negative here, cosine is negative there. You look at your unit circles, you should also hopefully recognize from your reference triangles that square root of 3 over 2 would be associated with a 30-degree reference angle. So inside here I can write 30s, but that's not my angle. The angle is the angle to get to it. So therefore, since we're talking about theta, theta will be 150 and theta will equal to 10 because I'm going to take 180 plus that 30 reference angle. Now, I'm actually done. I do not put plus 360k because I have a restriction. If I add 360 to my 150, it's well above 360. Not going to work. Not good enough. So be very careful on that, guys. Okay, now this problem I threw on here because we got to solve it just like before, but now it's in radians just so that we can practice ones that are in radians. I want you guys to do that. So I'm going to speed this one up. I'm going to actually do the solving for cosecant in one move because I subtracted it over, divide by 3. I'm hoping everybody would recognize that would happen. Cosecant is the sine, which actually becomes sine theta, because I'm going to change it to sine, and I'm flipping it at the same time, which means I need to flip, after I reduce, this to 1 over negative square root of 2. I can fix that. That's square root of 2 over 2. That's a negative. And sine. Where is sine negative? Sine is negative. It's the y values. And here's the cool thing, guys. If you're talking about sines and cosines and them ever equaling square root of 2 over 2's, you should hopefully understand that those are 45 degrees, but we're in radians. So therefore, pi is over 4. use those as references. So this particular angle, if you're looking at your unit circle, that means theta is equal to 5 pi over 4 because it gets 5 pi to get there, and 11 pi over 4, and those are your two answers. So they're not too bad. You got to get used to this idea that you're going to use your unit circle, use reference angles. Those are all things that will help you identify these things. The last problem that I like to do, again, I am between 0 and 360. It saves us a little bit of time so we don't have to add the 360k, but it's all doable. And so this one you have to factor. Ooh, factor. Actually, you don't have to factor if you don't absolutely want to. But I think it might be something really kind of cool. Do you guys notice that 4 is a perfect square? Cosine itself has a square on it, so therefore it's a perfect square, and 1's a perfect everything. Do you guys recognize that this can be factored to 2 cosine theta minus 1 and 2 cosine theta plus 1? And remember, when you have two factors multiplied that equal 0, they both get set equal to 0. So therefore, it becomes not just one problem, it becomes two problems. Okay, so I'm not going to completely finish it, but it follows the exact same thing as before. So where does cosine theta equal 1/2? And where does cosine theta equal negative 1/2? And again, we are between 0 and 360, so it actually is a fairly simple one with a 60-degree reference angle. So your homework then will be a worksheet that I will post for you guys in a couple different places so you guys can find it while we are on our little online learning. Have a great day.